Now let us go to the next experiment. It is an solving a difference equation. In order to solve a difference equation, let us consider a difference equation which is of order second order. This is a given considered equation. For this equation, now let us replace n with n minus 2 just to get an output equation y of n. Y of n minus 2 plus 2. Y is replaced with n minus 2 minus 1.5 y of n minus 2 plus 1 plus y of n minus 2 which is equal to 2 into x of n minus 2. Now minus 2 plus 2 will get cancelled. It will remain with y of n minus 1.5 y of n minus 1 plus y of n minus 2 equals 2 into x of n minus 2. From this, I'll just write an equation for output y of n. Y of n can be written as 1.5 y of n minus 1. If we take to the another side, it becomes positive. Plus, it becomes minus to the other side, y of n minus 2. And this will be same plus 2 into x of n minus 2. So this is an difference equation. For this difference equation, let us assume that x of n is equal to u of n. What is u of n? It is a unit step function whose value will be ranging from 0 to infinity. Amplitude will be always equal to 1. Okay, then we have a n minus 1, n minus 2 values. These are called as a past values for the output. For these two, let us consider a past values y of minus 2 as 1, y of minus 1 as 2. So these are the initial conditions which we have assumed. That's it. You can give any value. Now, for different n values, solve this equation, n number of values. So you can take 5, 10, etc. I'll just go for a first value where n is taken as 0. Y of 0 is equal to 1.5 y of 0 minus 1 minus y of 0 minus 2 plus 2 into x of 0 minus 2. 1.5 y of minus 1 y of minus 2 plus 2 into x of minus 2. X of minus 2. As I told you, the assumed input is unit step function. Unit step function don't have a value for its negative side. It is completely taken as 0. Then y of minus 1. It is the initial condition which is assumed to be 2. Write that. 1.5 into 2 minus y of minus 2. Minus 2 is taken as 1 value. So it is equal to 1. So now multiply these two, simplify this and get the value of y of 0. So similar to this, you can calculate this difference equation for a different values of small n. Next, let us see how to write a program for this equation, that is a second order difference equation. Now let us see how to write a program for the second order difference equation. Started with CLC, clear all, then enter the input x. X is equal to, for x we have assumed that as a unit step function u of n whose value will be present from 0 to infinity, magnitude will be 1. But it doesn't contain any previous values. Hence, here with respect to output, we are getting 2 previous values for the given equation. You need to take those values with respect to input as 0, 0, 0. Again, what is the magnitude of it? It is equal to 1. From where to where? It always start from any value. I'll give it to up to a count 10, 1, 10. So I'm considering a 10 different sequences value with respect to u of n, whose magnitude will be 1 itself. Use this once Matlab function. Then we have past values with respect to a output. Y past, I'll give it to a y past value of 1. That is understood that it is a y of minus 1 value. I'll give it as 2. Then y past of 2. Otherwise, you can here give as y past of, yes, it is 1, and here it is 2. It is 2, 1. Y 2 past values we have considered. One is 2 and another one is 1. So these are the past values. Now, where does the output will start now? The output window will be like this in a figure window. Thus, minus 2, minus 1, 0, 1, 2 up to 10. Okay. So, minus 2, minus 1 are the previous values, past values of y. But our actual output will start from 0th position. So, if you count that, where it has to start? 0, 1, 1, 2, 3. To get a 0th value, it is in a position of 3. For this, give a for loop. Assign to any variable called k. Where it has to start? From a 3rd position. Up to where? Up to a length of the input. Give it as length of x. It is starting from a 3rd position value and it is ending at the final length of a input, which we have taken it as 10. Now, this for loop should contain the given equation. Now, write it. Y is equal to 1.5 into y of, so since the variable used is k, write it as k minus 1 minus y of k minus 2 plus 2 into x of k minus 2. So, the variable used here, it is k, and the equation is written using a Matlab code. Then you need to plot it on the figure window. How to plot it? Use a stem. Where it has to start from? It has to start from a minus 2 value. Then length of output y minus, so what is the value you need to subtract? It has to, output should be displayed from 3rd position, so subtract it with minus 3. So this is a length defined with the discrete value. Now for this program, give x label, that is n values, and y label, magnitude, and a title of the program, which is a difference equation. For a difference equation, very important thing is to assume the previous value along with the given input data. And this is a complete logic for a 2nd order difference equation. Thank you. Now I'll show you how to execute difference equation program in a Matlab. Double click on the Matlab icon. Wait until you get a Matlab window. We got a Matlab window now. Select new script to file. Select a new file to type a program. Type the program in the editor window. After typing a program, save the file within the folder. File should be saved with Matlab extension .m. After saving the program, run the program. Change folder. So we got the values of a difference equation here. Since we have entered the equation directly, it is not asking for any input. So directly it has computed the values of difference equation, and the displayed values here will be plotted on the figure window with x-axis, y-axis and title. Thank you. Now let us move on to the computation of DFT and its IDFT. DFT, it is a very powerful computation tool to evaluate a Fourier transform on a digital computer. It is mainly used for a linear Friedrich operation. Now let us consider a DFT equation. X of k is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi k n by capital N, where k will be running from 0 to n minus 1. For this, either you can consider a 4-point DFT or a 8-point DFT. Now I have considered a 4-point DFT which is having 4 values in the sequence. Now apply the sequence to the general DFT equation. X of k is equal to summation n is equal to 0 to, according to the considered sequence, capital N value is 4. What is 4 minus 1? It is 3. X of n e power minus j 2 pi k n by capital N. As we know, k will be running from 0 to n minus 1. Take a first value of k, that is x of 0. What it becomes now? Summation n is equal to 0 to 3 x of n e power minus j 2 pi. What is k? It is 0 into n divided by capital N value is 4. Now first substitute a k value, k is equal to 0, then expand the end values for a equation. X of 0 e power 0 into anything is 0 plus x of 1. So since k itself is 0, for every exponential term we are going to get a value as 0, whatever the n value may be, plus x of 2 e power 0 plus x of 3 e power 0. E power 0 is 1, we know. What is x of 0? So this is the 0th position value, which is equal to 1, plus x of 1, it is also 1 into e power 0 is 1, 1 into 1 will be 1, plus what is x of 2? 0, 0 into anything will be 0, plus x of 3, it is also 0, 0 into any value will be equal to 0. What is x of 0 we are getting? It is equal to 2. Okay, this is an first DFT value for a position n is equal to 0. So this has to be repeated for n is equal to 1, 2, 3 like that based on the k values. K is equal to 1, k is equal to 2 and k is equal to 3. Then we are going to get a DFT values which is equal to x of k of within a flower bracket. You can write down that the first value is 2. It will be continued by solving the equation of DFT. Now let us see how we are going to write a program for endpoint DFT. So as we know, here we have considered only a single sequence. Keep clear all, then enter the input x through the input function, input of, enter the sequence. Then here only write what is the length of a considered sequence. Assign it to small n, input of, length of the sequence. Okay, then after this you need to write the DFT of the sequence. In order to perform a DFT in a Matlab, we have a function called FFT. So what is FFT? I'll assign to any other variable. I'll take it as Z. What is Z? It is a FFT which gives a DFT. First you need to write the input x, then you need to give a length n, x comma n. It gives you a DFT which is stored in Z. If you want, you can display these values using disp command. Disp of Z gives you a DFT of the considered sequence. Now for this DFT, you can also plot two different values. One is a magnitude and another one is an angle, which is a phase. You can calculate a magnitude by considering only absolute values of the DFT. Now I'll assign to any other variable. I'll just take it as Q. Q is equal to absolute value of, what is it? I'll take it as Z. Absolute value of Z. It gives the magnitude of the considered DFT. I'll display this on a figure window by giving subplot. Subplot of, I need a figure window like this. So one is for a absolute value, another for a phase, which is having a 2 rows and a single column. I'll give the first as 2 because I need a 2 rows and a single column. And in the first quadrant, the output going to be displayed with respect to absolute value. Now, define a length for this. What is the length? It is, assign it to a small n. Since we have already used small n, you can go for a capital N. It is starting from 0 to where it has to end. It has to end at n minus 1. Now give stem. Stem of n should be the first value, capital N. Then the absolute value will be the second one. This will give you an magnitude of the DFT. Then you can also give the angle of it. Assign to any other variable called, I'll give it to P. The phase value will be taken through the Matlab function angle of, where the DFT has been stored in a Z. Angle of Z. Again, give a subplot for that. In a second quadrant, you need to display that. Subplot 2, comma 1, comma 2. And the length is already defined. Give a stem. Stem of n, comma, q is absolute value, but I need a phase value. It is p. For this, you can give x label, which is a length, and a y label, which is a magnitude. Title, you can give it as a phase spectrum, and here also you can give x label, y label and title, which will be displayed in the figure window. How to calculate a phase and absolute values from the DFT output? So, DFT output will be generally in the rectangular form. If you convert a rectangular form into the polar form, what are the values we are going to get? So, one will be the absolute value and another one is a phase value. For a calculation purpose, you can have a conversion from rectangular to polar to get absolute values and angle values.
Now I'll show you how to execute endpoint DFT program in a Matlab. Double click on the Matlab icon. Wait until you get a Matlab window. So now we got a Matlab window, but we need a new script file to type a new program. Select new script. You'll get an editor window here. Type the program in that. After typing the program, you need to save this program in a specified folder. Save it. With .m extension. After saving the program, run the program. Give change folder. Then it will ask for the sequence. Enter the sequence with square bracket, either giving comma or space. I'll give 1, 1, 0, 0, close the square bracket. Press enter to see the output. So also you need to enter what is the length of the sequence. So the length of the sequence is 4. Give 4 because we have entered 4 values. Enter. Now in the DFT program we have plotted the two different values. One is a magnitude value and another one is a phase value. So you need to see the values. These are the magnitude and phase spectrum. How to calculate this? By converting a rectangular values of DFT into polar form, you are able to see what is a magnitude value and what is a phase value. Thank you.